Hello, I hope all of you are doing well. My name is Shriya Bansal, and now we are quickly going to get started and talk about the very first aspect of the secondary storage over here. Okay, so the idea is that whenever we talk about secondary storage, first let's talk about that also a little bit. Secondary storage basically devices are those devices whose memory is non-volatile, meaning the stored data. Okay, secondary storage devices are always those devices in which the memory is non-volatile. That means that the storage will remain intact even after the system is turned off. Even after the system is turned off. Okay, here are a few things that is worth noting about it, that secondary storage is also known as auxiliary storage. Okay, secondly, secondary storage is obviously less expensive compared to RAM. Okay, thirdly, the speed of the secondary storage is less than the speed of the primary storage or the main memory. Okay, and here the data which is less frequently accessed is kept in the secondary storage. Okay, and a few examples for that would be, example will be magnetic disk, magnetic tapes, right? And thumb drives, etc. are all a part of this over here. So in this module, we are going to focus very specifically on magnetic disks, okay, and talk in detail about magnetic disk. All right. So magnetic disk actually provides the bulk of the secondary storage for a modern computer system. That means magnetic disks actually are used to store the bulk of the data that is actually stored in your computer system. And now how the structure for a magnetic disk is decided is that each disk has a platter, okay, like a circular shape, like a CD. Okay, so magnetic disk is nothing but different platters, like different CDs stacked up on top of one another, and the CD always has two sides, like above and below. Okay, and common platter diameters. Okay, if I have a disc kind of a structure over here, you can see the normal diameter of a single platter is usually from 1.8 to 5.25 inches. Okay, and the surfaces of both the platters are covered with a magnetic material, hence it is known as the magnetic disk. Okay, always remember that in modern computers, most of the secondary storage that you will ever come across is going to be in the form of magnetic disk. Okay, hence obviously it becomes very important to know the structure of the magnetic disk to understand how the data in the disk can be accessed by the computer. Okay, now a read-write head basically flies just above each surface of every platter. So what happens is you have all those CDs kind of a structure, platter stacked up on top of one another, and along with that there is a read-write head. You can see this arm assembly. Okay, that is for this arm assembly, for every platter there is a read-write head on top of it. See here, the read-write head is basically present on top, or it is flying, okay, rotating on top of every platter. Okay, The heads are basically attached to the disc arm. Okay, here you can see the heads of the read write are basically attached to the disc arm, right, which moves all the heads as a unit. Okay, all the heads together move as a unit, and the surface of each platter, okay, is logically divided into circular tracks. So let's think of it like this. I'm showing you a top view. Let's say if this is a disc. Now this disc, as you would have seen also, like, is always divided into tracks. This is one track. This is another track. This is another track. This is another track. And this is another track. Okay. So this is how the entire platter surface is basically divided into logical circular tracks, which are subdivided into sectors. So every track is basically divided into sectors. Let's say if this I take the blue track, it is basically divided into multiple sectors. Okay. Now the set of the tracks that are at one arm position basically form a cylinder. For that, you should see this diagram only. You can see that there are certain set of tracks, okay, which are present on every platter, and when you stack all of these tracks together, it basically, you can see, uniformly makes a cylinder. Okay, as you can see over here, all those stacks which are at the same position on different platter basically makes a hollow cylinder kind of a structure. Okay. Now, there may be in this way thousands of concentric circles in a disk drive, because you just have to map the tracks, correct? And each track can have hundreds of sectors. Okay. So, there can be thousands of concentric cylinders in a drive, right? And for each drive, there can be for each track, there can be hundreds of sectors in it. Okay, and the storage capacity of common disk drives. Okay, what is the storage capacity of common disk drives? It is basically stored in gigabytes, and this would be your example. You can see there's a spindle which helps for the rotation of the platters. Cylinder is like structure form. There is a track, and in that track we have several sectors, and we also have read write heads which are at the very end of the arm attached to the arm assembly. Okay, so that is what the idea is. Always remember, a magnetic disc contains several platter. Each platter is divided into circular shaped tracks, and every track is further divided into sectors. Okay, and the tracks of the same distance basically from the center basically form a cylinder. Okay, so that's what the overall idea is. So whenever we talk about when the idea of magnetic disc, and whenever the magnetic disc is in use, there is a driver motor, okay, that spins the disc at a very high speed. Remember, most drives rotate around 60 to 200 times per second, okay, and disc speed basically has two parts, okay. Two things that you have to remember. First is the transfer rate, at which the data flows from the drive to the computer. That means how much time does the read write heads basically take to read the data from the computer. Okay, and the positioning time or the random access time basically is considered as a time that consists of the seek time and the rotational latency. Okay, so remember, random access time is basically the sum of seek time plus rotational latency. And what is the seek time? The seek time is when you have a disk arm, but the disk arm has to move to the desired cylinder, correct? And rotational latency is the time for the desired, so you've reached to the desired cylinder, you've reached to the desired track, but that's not enough. In order to read the data is present into sectors, so you have to reach and rotate the track in order to reach to the correct sector as well. Okay, that is known as rotational latency. Okay, seek time is to go to the desired cylinder. After you reach the desired cylinder, the desired track, the time it takes to reach to the desired sector in that track is known as rotational latency. And random access time is nothing but seek time plus rotational latency. Now, a typical disk can transfer several megabytes of data per second. Okay, and they have seek times and rotational latencies of several milliseconds. Okay, so what happens is typically when you have disk, they can transfer several megabytes of data per second. Okay, and here you can see that the capacity of a magnetic disk, known by the C as for capacity, right? It is usually S into T into P into N, which is S is the number of surfaces you have. So if you have 10 disks, there are 20 surfaces, top and below, right? I told you every platter has 2 surfaces. T is the number of tracks you have in a surface. P is the number of sectors per track, and N is the size of each sector. Multiplying all of these factors basically tells you the total capacity of the magnetic disk. Okay. One of the responsibilities of always the operating system, is to use the hardware efficiently, right? For the disk drives, meeting this responsibility means like efficient use of magnetic disk basically means having fast access time and large disk bandwidth. Okay, and this access time has 2 major components. First is the seek time only, to basically have the disk arm move to the required heads of the cylinder. Okay, and the rotational latency is the time that you have to wait for the disk, to go to the desired sector of the disk head. Okay, and the disk bandwidth, what is disk bandwidth? It is the total number of bytes transferred, okay, between or starting from the time, right? It is the total number of bytes transferred divided by the total time between the first request for the service and the completion of the last transfer. That tells you the bandwidth of a disk. Okay, and if you have to work on a very fast and if you have to make sure that your hardware is very effective, operating system needs to take care that fast access time is provided as well as large disk bandwidth is provided. Okay, and we can improve both the access time and the bandwidth, right, by basically scheduling the request of input output in a good order. Okay, and that is why in the next video you will also see a lot of disk scheduling algorithms. Okay, what do these disk scheduling algorithms basically do is they try to do the scheduling of your request in a very optimized manner. Okay, so that you can actually schedule all your requests and take care of your idea that based on your requirement, how effectively do you want the scheduling to take place. Okay. So just to quickly recap, what all did we cover? First, we talked about secondary storage, which include magnetic disk, magnetic tapes, hard disk, and like removable thumb drives, right? Out of these, the most commonly used is magnetic disk, wherein we have cylinders. For cylinders, we have tracks and then sectors where the actual information is stored. Then we talked about 2-3 terminologies also, whereas the transfer rate is the rate at which the data flows from the drive to the computer. Seek time is when the disk arm has to reach to the required cylinder, and rotational latency is for the time that the disk arm takes to reach to the required sector. Okay, and this is how we calculate the capacity of magnetic disk into S into T into P into N. In order to make sure the hardware is used effectively, the operating system has to take care of the fact that the access time is fast for the disk and there is large disk bandwidth. Okay, so now what we're going to do is in the next video, we are going to start with the disk scheduling algorithms, right? Where we are going to talk in detail what all disk schedulings are available, why do we really use which one for what, and what are the advantages and the disadvantages for all of them. All right. So I hope this is clear to everyone and we'll definitely meet in the next video. Bye.